Today's webinar, we will be focusing specifically on key differences between using a standard spectral resolution spectrometer versus what the benefits are to using a higher spectral resolution spectrometer. We'll have us first discussing the differences between our OR Express and our OR Expert. We'll be looking at relevant examples of minerals throughout different mining applications and how spectral resolution differs. And to wrap things up, we will be looking at some of those minerals in our EasyID mineral identification software and check out our GeoSpec high resolution library. The two different instruments that we'll be discussing today are the OR Express and OR Expert. Our OR Express is the standard spectral resolution spectrometer that we offer, which is full range and has a spectral resolution of 2.8 nanometers in the UV, 8 nanometers in SWIR 1, and 6 nanometers in SWIR 2. Now, when we talk about standard resolution, that is referring to the lowest spectral resolution that is accepted throughout the mining and geological industry when it comes to spectrometer. If you're new to the technology, the higher this number means the lower spectral resolution you're actually getting. So that's why that means that this is the lowest spectral resolution that is accepted in terms of being a standard throughout our industry. However, the OR Expert, which is this yellow guy right here, this happens to be the highest spectral resolution spectrometer on the market. It gives you about double the resolution than you would get with the OR Express. So this actually gives you 1.5 nanometers in the UV, 3 nanometers in SWIR 1, and 3.8 nanometers in SWIR 2. Now, the higher resolution with this OR Expert allows for better detail in your mineral spectra, and it actually provides additional absorption features that are not visible with a standard resolution spectrometer, which we will see later on in the presentation. So both of these instruments are field portable. They both go in a backpack and operate via Bluetooth to a rugged tablet. You get about 8 hours worth of field work with batteries provided. Now, if you're working in the lab or in the office or have access to a power outlet, you can just use the power supply instead and actually run the software on a desktop or PC. We do have two size contact probes available, a 10 millimeter contact probe and a 3 millimeter contact probe. We have a fantastic mineral identification software called EasyID that I will be demonstrating at the end of the webinar. Now, it features 3 built-in mineral libraries, the USGS, SpecMin, and GeoSpec. And also it gives the user the ability to create their own mineral library to use. There are mineral scalars available that provide the user with information on geochemical conditions of their sample. This software runs on a PC or on a rugged field tablet and also gives the user the option to create mineral presets to focus on very specific mineral groups of interest, like the clays, for example. So speaking of mineral libraries, since we now have high resolution spectrometers on the market, there is now a need for high resolution mineral libraries. Using standard resolution mineral libraries is starting to become outdated, and there is a need for research institutions and mining companies to produce high-resolution libraries. Now, we do have a built-in high-resolution library called GeoSpec. And it was created at the Colorado School of Mines Mineral Museum in Golden, Colorado, and features 688 spectra for 239 different minerals, all of which provide different alteration types for a better analysis. All right, so let's go look at some examples of what standard versus high resolution data looks like, and also applications that the high resolution can really benefit with. So first, we are going to talk about rare earths. So rare earth elements have become one of the most critical metals to our modernized world. In particular, we're going to talk about some light rare earth elements in this example. So light rare earths are a subset of the lanthanide series of rare earth elements, which are themselves a special set of transition metals. So the light rare earth elements include lanthanum, cerium, praseodymium, neodymium, and samarium. Minerals such as bastnäsite and alunite are light rare earth bearing minerals. So in this example, we will be looking at bastnäsite. So bastnäsite is a carbonate mineral, and here is a plot showing bastnäsite in standard versus high resolution. The standard being in the red with the Ore Express, and the Ore Expert being in the green. So the Ore Express shows all of the typical absorption features of a pure bastnäsite. However, the high resolution Ore Expert shows much more detail and additional absorption features that are not present with the Ore Express. So this increase in spectral resolution aids in a better understanding and actually makes band assignment more clear than with using just a standard spectral resolution like the Ore Express. So if you're someone who is wanting to not only identify rare earth minerals, but you're also wanting to distinguish between them, the Ore Expert really aids in giving better spectral detail. So for example, in this bastnäsite example here at 570 nanometers here, you can see a spectral increase where you've got a doublet with the Ore Expert that is not there with the Ore Express. Also in the 700 nanometer region, you've got much more detail and additional absorption features here. And also the 800 to 900 nanometer region as well. The next example is a nickel application. So this is going to be an application where the Ore Expert can really benefit you. This is not an application that a standard resolution spectrometer can do. So nickel laterites actually dominate the global supply for nickel. So it is very important in this application to be able to distinguish between iron serpentine and magnesium serpentine. Iron serpentine is actually used as a proxy for nickel exploration. So in this plot, we have an iron serpentine, which is the green, and a magnesium serpentine in the red. Both of these were measured with the Ore Expert. And as you can see with the magnesium sample, there is actually a doublet right here at like 2340 nanometers. That is not going to be present with an iron serpentine. So this application can only be done with a high resolution Ore Expert because the lower resolution of the Ore Express does not give you the capability to distinguish between these two types of serpentine. So again, this application is a valuable case for the Ore Expert in particular. So using the geologic setting of talc deposits as an indicator of amphibole asbestos content, this has been around for a while as an environmental application. So When looking for an iron-bearing talc, spectrally, the mineral has an Fe2 plus feature around 1,000 nanometers that then produces an additional hydroxyl band in the form of a triplet at 1,400 nanometers from the Fe cation that is not present with a standard resolution spectrometer. So in this plot here, the blue is the OR Expert and the green is the OR Express. So again, with the OR Express, it is just one single feature, whereas with the OR Expert, you've actually got a triplet there. So alunite characteristics can provide a good indication of gold ore potential in a high sulfidation epithermal system. So any of you gold exploration folks, this is going to be right up your alley, this specific application here. Now, as you know, alunite is a potassium sulfate mineral that forms in hydrothermal systems. So sulfates such as alunite and jarosite are common in these hydrothermal environments, and therefore they do have distinctive spectra. So these alunites actually have the potential to delineate zoning based on the chemical and temperature changes in that hydrothermal system. So this specific application in particular, you can actually measure the shift in the alunite from potassium rich to sodic. So a user can have a better understanding of that mineral alteration and can use this data really to vector to mineralization. So this shift is typically seen in the 1480 to 1490 nanometer region and is thought to be a record of the mineralizing effect of the magmatic and meteoric fluids. So using an ultra high resolution spectrometer like the OR Expert, you can actually distinguish between the potassic alunite and the sodic alunite by seeing the spectral shift here in the 1480 to 1490 nanometer region more visibly. So the high resolution of the OR Expert also provides an additional absorption features and extra detail that is not present with a standard resolution spectrometer. So this doublet right here at around 1420 nanometers. So this section right here, this in a normal standard resolution spectrometer is one single feature, whereas in the high resolution OR Expert, we've actually got a doublet here. So this can actually help you, especially if you're looking at pH changes, going from alunite to jarosite or anything like that. You can use this feature here to delineate whether it is alunite or not. Clays. So the accurate identification of clays in mineral assemblages can provide key indicators that mineralized systems are present or absent. So using a field portable spectrometer, you can actually identify different clays in samples and note where alteration occurs, even in situations where, visual identification is not possible. So mapping of alteration zones can actually provide very useful information, and these can indicate vectors to even undiscovered economically viable deposits. So for example, where low sulfidation assemblages might include illite, montmorillonite, and sericite, high sulfidation assemblages might include kaolinite and alunite. So the higher resolution of the OR Expert allows you to see more features and more detail in your measurements. So this close-up here shows the OR Expert in the blue versus the OR Express in the green. And again, it's the same case here. The green in the OR Express, you have just a doublet here at 1400, whereas in the OR Expert, you've actually got a triplet there. So the high resolution of the OR Express, when it comes to kaolinite in particular, can really aid in actually helping you figure out, well, is my kaolinite weathered, or was it produced at a higher temperature? So applications like that are very, very good for the ore expert. All right, so anyone working on pegmatites or brines, especially for lithium exploration, knows that lepidolite is a source of lithium in mineable quantities. Lithium and muscovite are actually two micas that often occur together, especially if you're working in pegmatites. So there is a need to distinguish between the muscovite and lepidolite, which is very hard to do with just a standard spectral resolution spectrometer. So in this plot, here is a standard resolution lepidolite in the green, and the red is taken with the ore expert. So as you can see, there is actually an additional feature here at 1400 nanometers with the ore expert. And that is directly correlated to the hydroxyl band plus a lithium cation, which is causing that additional feature. So we will look at this specific example in EasyID here soon. But just to point out that if you were to compare these two in a standard resolution manner, this feature here would look exactly the same. Whereas now that we're seeing it in high resolution, the ore expert actually points out that additional feature right here. So yeah, let's go over to EasyID and look at some of these examples. So we're going to first start out with the lepidolite example. For those of you who have never seen EasyID or never seen a demo of it or used it, just very quickly, this is our mineral identification software where the red line in the plot is going to be our library scan of a mineral. And the blue plot is actually our measurement that we take, so our sample we're wanting to measure. So this software does a match analysis to tell you what minerals are within your sample. So we're just going to zoom in here to the 1400 nanometer region. So before I move over to the high resolution mineral library, I wanted to show you guys just exactly how it looks when you compare a high resolution lepidolite to a low resolution library. So the blue line is our lepidolite scan, and the red line is what is actually being matched to the library. So remember I said that if you're using a lower resolution spectrometer, it's going to try and match it to muscovite, which is exactly what it's doing. So right here it's saying library spectrum muscovite. It's giving me a correlation score. So in a lower resolution library, it can't take into account these additional features. So it thinks it's muscovite. But if I actually go to our high resolution library, there's the lepidolite right there. So now it is matching to the lepidolite based upon those very specific features there. So let's actually move over to our next example. We're going to look at a rare earth sample. So right now we are comparing it to the high resolution library. So it is matching up pretty much perfectly. But let me go back to a lower resolution library so that you can physically see the differences. I'll zoom in a little bit more here. So again, bastnäsite is a rare earth. So in this region here is where a lot of the rare earth absorption features occur. And with the higher resolution, we're seeing a lot more detail in our spectra. So if you are specifically working on rare earths, the Ore Expert works tremendously with this application. I can't express enough how much the Ore Expert aids specifically with rare earths, because you do get so much more detail here in the spectra. So the next one we'll look at is the kaolinite. So we've actually got two regions in the kaolinite that you really see the difference in. So I'll start out with the 1400 region. So this is comparing it against the standard resolution library again, where the red is the standard. So normally, if you scan a kaolinite, you're only going to see a doublet here. But with the Ore Expert, you've got a triplet here. Same thing if we go down to 2200 nanometers, where our ALOH is. Standardly, it's a doublet. But with the Ore Expert, you do have a triplet here. So again, you can actually use the shift and the additional features here to actually aid you in figuring out, okay, well, is this kaolinite a weathered kaolinite? Is at a high temperature? If you're looking to distinguish between the kaolin group minerals, the high resolution really does a fantastic job of that. So we'll go back here. So just to wrap things up, as you can see, the Ore Expert really shows additional features and allows for more detail in your mineral spectra with that increased resolution, which is not present with a standard resolution spectrometer like the Ore Express. The high resolution is a great tool, especially for those alteration applications, as it actually enhances the distinction between the different species. So as our world is modernizing and technology is getting better, mining companies and research institutions are actually turning to higher resolution spectrometers, as this will soon become the new standard throughout the industry, probably in about the next 5 years or so. So there's also a need for updating those mineral libraries using high resolution. So, using our built-in GeoSpec library is a good start. So thank you all for attending this webinar. And if you have any questions, you can reach out to me directly, Lori Shelton at spectralevolution.com. And make sure that you follow us on LinkedIn.